So hi everyone. My name is Amit Bar. Currently, I am an analog design engineer at Lemon Flip Solution. Okay, and it like the office is in Kolkata, India. So the profile is based on Analog VLSI. So today I will be sharing my interview experience at for the Lemon Flip Solutions interview. Okay. So, and I completed my Bachelor of Engineering degree from Jadavpur University, Kolkata. Okay, so let discuss first how I apply for this post. Okay, so I applied from via LinkedIn. Okay, I applied via LinkedIn. Okay, and like applying like after 1 week or 10 days I got a call from Lemon Flip Solution for the interview. Okay, and the position was, I said previously, analog design engineer. Okay, so basically this is like their company location like currently is in Hyderabad, uh, Bhubaneswar and Kolkata, and they are trying to build their office in Bangalore. Like it will be in coming days. Okay, like between 2 to 3 months. Okay, so after like I decide when to give my interview. Okay, so the interview firstly sir asked me to introduce myself, so I introduced myself then. And the first question, like sir was checking my basics. Okay, so the first question was this. So Sarah was asking what will be the voltage at this node. Okay, so this was 3K and 1K. So I told intuitively, what I told is I told in this in this section total resistance is 4K, and across this 4K resistance the like potential difference is 4 volt, right? 5 minus 1 volt, like 4 volts. Okay, 5 minus 1. So then I tell, if we have 4K resistance and 4 volt potential difference across it, so 1 milliamps current will flowing through this path. Okay, so if 1 milliampere current is flowing through this path, so there will be a 3 voltage drop and there will be a 1 voltage drop. So at this node, this potential will be this 1 voltage drop across 1K resistance plus this 1 volt source. So V out will be 2 volts. So I told like exactly what I am telling now. So I told intuitively. Okay, so this was the answer. Then then sir asked me this question. This was my second question. I think this was my second question. Yes. So this was like, let's say I naught, and this was C, and the switch is opening at t equals 0. So sir, given this circuit, says that initially the switch is closed. Okay, but at t equals 0 plus the switch is open. So sir firstly asks uh, wow, what will be the voltage equation at this node with respect to time. Okay, so you know that if this is open circuit, the circuit will look like simply this. Okay, so this is nothing but a constant current source charging the capacitor. Okay, so this will be a ramp. Okay, okay. So we know that the capacitor integrate the current. Okay, so I tell that, and this is a constant current, so V out will be nothing but I naught by C into T, right? So this will be the answer. So then sir asked me what will be the nature of this voltage waveform. So I told that this will be a ramp. So this will be the voltage waveform. So V out versus T, right? You can see the see from this equation as well. Okay, then sir asked me again, if I naught is a sinusoidal signal like sine omega t, what will be the output nature. So I told that if like capacitor is integrate the current, so voltage output waveform will be cos directly. I directly say that. So then sir said okay. So he moved to next question. Okay, I think the third question was this. Okay. Yes, charge sharing probably, yes. So this will be, there is a switch present at t equals 0, it is closing. There will be another cap. So this value is 2C, I guess. Yes, 2C. This is C, and this is on volt charge initially, and this is 5 volt charge initially, and this is the V out. So this was my, I guess, third problem, and sir said that what will be the steady state output voltage at this node. Okay, at this node after t, like at steady state, and the switch is closing after t equals 0. Okay, so then I said I can solve this problem in 2 3 ways. So I will solve here. We know that the initial charge is always equal to the final charge. Okay, so what will, like at t equals 0 minus, the switch is open, right? So this was the circuit. So what, this is C, this is 1 volt, this is 2C, this is 5 volt. Okay, so what was my initial charge? So initial charge is nothing but Q equal CV, right? So C value is C, or voltage is on, so this is on voltage into C, so this is C. This is for this cap, right? And what will be like initial charge. Okay, this will be for this, and plus the charge will be here is 5 volts into 2C. Okay, so this was my initial charge, this is 11C. And for final charge we can see that this will be a short circuit, so this two capacitor comes parallel. Okay, and only 1 volt is there, so final charge will be V naught into, if two capacitor is in parallel, so equivalent will be this plus this, so this will be 3C. So we know that the initial charge equal to the final charge, right? So we have 11C equals V naught into 3C. So V out is nothing but 11 by C volts. So this was the answer, and this was exactly correct answer. I think sir asked me after that was, the answer asked me what you have done like till now. So I said that I have done op-amp design, op-amp design. Okay, like two-stage op-amp, single stage op-amp, like block level to transistor level. Okay, block level to transistor level. So both single and double stage, single stage and two stage. Okay, two stage. So then sir asked me draw the block level diagram of two stage Miller compensation op-amp. Okay, two stage Miller's compensation op-amp. Okay, so I draw the following picture, like following diagram. So we know that this is the two-stage Miller compensation at block level, like at transconductor level as a block. So this is our GM1, this is GM2, this is our Miller cap, let's CC. So there will be a, this is the output conductance of this transconductor, and this is the C1, and this will be our load. Okay, let okay, CL and GL. Okay, GOL. Okay, so and this is minus, this is plus, this is minus, this is plus, and this is grounded. Okay, and this is our op amp. This is minus, this is plus, and this is our output. Like we know that op amp has two input and one output. So this is our output and this is our two input. Okay, so then sir asks me what is the DC gain. So I have analyzed this circuit like so many times. So I direct like DC gain. What is DC gain? DC gain, we can see that at DC the all the capacitor are open circuit. Okay, so what will be the gain? The DC gain will be nothing but let A0. This is GM1 by GO1, like gain of this block into gain of this block. So this will be nothing but GM2 by GOL. Okay, so this is the DC gain. Then sir asks me like how many poles are there. So I said 2, and then sir asked me like what will be the pole locations, 2 pole locations. Sir didn't ask me about the 0. Okay, then sir asked me about 2 pole locations. So I do this. This is approximately P1. This is our dominant pole as well. Okay, dominant pole. So dominant pole is here. This is P1 and this is P2. Okay, so dominant pole will be GO1 divided by C1 plus CC into GM2 by GOL plus 1. This is all approximate value. Okay, and the pole 2 value will be GM2 times CC by CC plus C1 plus GOL whole divided by CL plus CC1 by CC plus C1. Okay, so this was the 2 pole locations, and then sir again like asked me to modify this. As we can see that GM2 is like getter is very getter than GOL. Okay, and CL is very greater than like CC. CC is very greater than C1. So then sir asked me to modify this circuit. Okay, so like if both the pole locations, okay, then I do that. Okay, so you can do the same. Like if you consider this, there will be some reduced expression. Okay, so this was the question. So after that, then he asked that another circuit like this circuit like uh, transformer based circuit. Okay, so this was like this. So then sir said this is 1:1 transformer, and here we are giving sine omega t. Okay, and there is a constant current source of 100 milliamps, and there is a resistance, and the resistance value is on a 10 ohm, and sir asked to find what will be the voltage at this node. So I told intuitively, as this is a 1:1 transformer, so voltage drop across these terminals will be sine omega t as well, and a constant current, this is 100 milli. Okay, and as constant current source, the constant current source is flowing through this way, so there will be a voltage drop of across 10 ohm will be nothing but this current into this resistance. So this will be 1000 millivolts. So this will be 1 volt. So if you do, like, if you can do the KVL as well, but we can directly see that this voltage is nothing but this voltage plus this voltage, right? So V out is nothing but sine omega t plus this 1 voltage, right? So this was the answer. So then he asked me which book I follow, okay, for analog IC design. So I said Vezad Raza Visar's book, okay. And as I am from Jadavpur University, so sir asked me who are the professors like teaches like teach the like taught us the analog circuit, okay. So I told two professors name. Then, like, this was my interview experience, and I got selected at the, like, immediately after the interview, okay. And honestly speaking, I gave 100%, like, I believe I got, like, I gave like all the answer 100% correctly, okay. So this was my interview experience for the analog design engineer profile at 11 Flip Solution, Kolkata, okay. So I think this type of question is basically asked for entry level analog IC design engineers. So I think it will be helpful for you as well. Okay. Uh, let me check. I am forgetting something or not. Okay. 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 This was all. Okay. And the interview duration was around like 30 minutes. Around 30 minutes. Okay. So thank you everyone. If this video helps you, so you can give your valuable feedback and subscribe our channel as well. Thank you.